Sperm meets egg, and the miraculous journey towards human life begins. But in this case, something even more extraordinary happens. The fertilized egg splits into two, creating identical twins. Then each egg splits again, estimated as a 1 in 64 million occurrence. Identical quads. For the first time, revolutionary new imaging techniques allow us to follow in minute detail 3 very different pregnancies. These identical twins, these triplets conceived on different days, and these remarkable quads. Through them, we explore the stories and science of human reproduction's ultimate marvel, the miracle of multiple births. This child is about to be born. But for her, the womb has been no placid ride. Nor will her birth be the first time she has met other humans. She has been sharing this space with not 1, but 3 siblings. Each has grown from an egg, smaller than the size of a grain of sand. Solitary and unaware. To one of 4 sisters, touching, reacting, and what looks like kissing. They have fought for nourishment and space. Yet they lay the foundation for a lifetime of warmth, comfort, and companionship. They've helped each other develop, and they've forged a connection and behavioral patterns that will define them for the rest of their lives. Their journey begins, as for most of us, with the act of conception. During this, a normal, healthy man releases approximately 300 million sperm into a woman's vagina. The sperm swim up the reproductive tract towards the fallopian tubes, where an unfertilized egg is the prize. During each reproductive cycle, a woman usually releases 1 egg. The first sperm to reach it and penetrate its outer coating will be the winner. Once inside the egg, the head of the sperm, containing the DNA from the father, and the nucleus of the egg, containing the mother's DNA, are brought together by tiny fibers called centrosomes. The 2 sets of DNA fuse. Conception has occurred. This is the first cell of what will become a new human life. In the first few hours, the fertilized egg begins its journey down the fallopian tube towards the uterus. One day later, it has divided for the first time. On day 2, it numbers 2 to 4 cells. On day 3, 8 cells. By day 5, the embryo is now called a blastocyst. Its 70 to 120 cells have formed 2 distinct sections. The inner cell mass will become the body. The outer, ring-shaped section, called the trophectoderm, the all-important placenta. At around day 6, the blastocyst finally hatches through the eggshell and attaches to the lining of the uterus. It begins to burrow. Here it will remain for the next 39 weeks, growing from blastocyst to embryo, from embryo to fetus, and from fetus to fully grown baby. But in a tiny number of cases, approximately 1 in 250, the egg does something extraordinary. It splits into 2, duplicating itself and giving rise to 2 separate fertilized eggs. Separate, but identical. No one fully understands why this happens. But one clue may lie in the very nature of the eggs. The greatest number of identicals are conceived by women who are at the beginning or the very end of their reproductive years. Some scientists believe that in older women the eggs are weaker and more vulnerable to splitting. What we do know for certain, if it hasn't happened within the first 14 days after conception, it never will. Identicals share one of the closest human relationships biologically. They are likely to grow up looking and sounding extremely similar. Yet they're not a 100% match. A small number of genes in the mother's egg sit outside the nucleus. Known as mitochondrial DNA, these genes can mutate after the egg has split, subtly modifying the way that each embryo grows. Small differences in height, build, and even personality will become more and more apparent as the twins grow up and reach maturity. This is why some scientists are now wary of using the term identical and prefer instead monozygotic or single-egg twins. As with singletons, each will develop inside 2 sacs. An outer chorion attached to the placenta and an inner amnion or amniotic sac, fusing over time. Some twins share a chorion. A very few even share an amnion. As they develop, they will be competing for space and for nutrition from their mother. Yet despite this, they may also eventually share the deepest, most enduring bond. This woman, Julie, is extremely unusual. Though she doesn't know it, her single egg has split not into 2, but 4. She is probably one of only a handful of women in the world currently pregnant with these unusual identical quads. The chances are 1 in 64 million. These tiny fetuses each have their own amnion, but they all share a chorion and with it a single placenta. As a result, they will share a single source of food and oxygen for 30 long weeks. They will be biologically among the closest set of individuals the human body can conceive. This woman, Rachel, will undergo a totally different process. She has released 2 eggs, one from each ovary, and a different sperm has fertilized each one. She is pregnant with fraternal twins, sometimes called double egg or dizygotic twins. It's just like 2 separate pregnancies that happen to have occurred on the same day. Unlike identicals, fraternals are genetically no different from regular brothers and sisters who share only half their genes. Themselves into 2, forming the primary connections between the placenta and the mother's bloodstream. Now sees the first change in the clump of cells inside the blastocyst. First, 2 layers form. By day 9, the 2 layers have become a disc with a cavity above it, the future amniotic sac, and a cavity below, the future yolk sac. Halfway down the disc, a groove appears, called the primitive streak. Cells migrate towards the streak and pour themselves into it. By day 14, on one edge of this primitive streak, another patch forms, known as the organizer. Until this point, all the developing cells in the body have been the same. They're known as stem cells. Now, each cell flows over the organizer, and as it does so, it is assigned its fate. Some will become part of a limb, some part of a hand, some a cell in the lens of an eye. The crest of the tiny embryo doesn't yet resemble a head. But by day 15, nerve cells are beginning to form in what will become the brain, as well as in the spinal column, all exposed and totally unprotected by skin or bone. One of the first organs to form is the heart. Until now, it's been a dormant clump of muscle cells. Then, around day 22, one cell spontaneously contracts, triggering its neighbors and setting off a chain reaction until the entire vessel is beating. It begins to pump primitive blood cells through veins no thicker than a hair, carrying vital supplies of food and oxygen to fuel the frantic growth. Later on, when the brain is more fully developed, it will regulate the rate of contraction, increasing the speed when more fuel is needed, and slowing it when the body is at rest. In the average lifetime, a heart will beat 3 billion times. This is 32-year-old Jennifer. 1 month ago, she released a single egg, which was fertilized. The egg then split to become identical twins. But the story doesn't end there. Jennifer then released a second egg. This too was fertilized. The identicals are joined in the womb by the third fraternal sibling. This process is known as superfecundation, from the Latin meaning extra fertilization. It's extremely rare. In Jennifer's case, the second egg was fertilized by the surviving sperm from the first active intercourse. But this is not always the case. Technically, each egg could have been fertilized by sperm from 2 different ejaculates, even from 2 different men. It's estimated that for every 400 sets of fraternals, 1 is made up of twins who will each have a different father. Our 3 sets of embryos have now reached 6 weeks. They are nearly an inch long. Now the basic eyeball is 85% formed, and there is the beginnings of a rudimentary lens. At this stage, the womb can hold many. The record is 15, but only 9 have ever made it to birth. In this scan, we see 5 fetuses at only a few weeks old. Though Jennifer's triplets were conceived naturally, perhaps the result of superfecundation, most higher numbers of multiples have occurred thanks to modern fertility treatments. In some cases, the woman takes drugs which stimulate the production of many eggs, several of which become fertilized naturally through sex. In other cases, in vitro fertilization is used. Here, eggs are fertilized outside the womb in a petri dish. Then 2 or more are put back into the uterus. Since the advent of fertility treatment in the late 1970s, the number of twins has increased by 50%. The number of triplets and quads has grown by more than 400%. The embryos are now 8 weeks old. They have grown to about 3 centimeters in length, the size of the end of your thumb. The eyeball is now complete. The lens is almost formed too. But the muscle that will focus it hasn't grown and won't be fully functional until the age of 6 months. In another couple of weeks, the fetus will have eyelids as well. The head, one of the earliest structures to grow, is massive, a third the size of the fetal body. The embryo is starting to look something like a tiny human, and now becomes known as a fetus, from the Latin meaning offspring. By 9 weeks, the brain is developing fast. On average, 2.5 million new nerve cells created every minute, and 100 billion by birth. Still, thus far, the baby's body now begins to twitch. The movements are involuntary reflex spasms, not yet controlled by the brain. They play a vital role in stimulating the growth of muscles and in strengthening the joints. The heart is also picking up speed. After starting 3 weeks into development at 75 beats per minute, it gradually increases until at 9 weeks it reaches a frenetic 165 beats. This is as fast as it will ever get. It slows in the latter half of pregnancy to 125 to 150 beats. A child's heart beats on average 70 to 110 times a minute. An adult heart, 70 to 80 times a minute. At between 10 and 14 weeks, a pregnant woman will usually go for her first scan. Ultrasound has revolutionized our understanding of fetal development. These pictures are produced by sending ultra-high-frequency sound waves, far too high for us to hear, from the probe into the body of the mother. The sound waves penetrate soft tissue, but bounce back off denser structures like bone. From the pattern of reflected waves, the computer creates an image of the hidden fetus. We are now at 18 weeks, halfway through gestation. And we're approaching the stage when our fetus's senses will really start to develop. The fetus's digestive system is beginning to function. Although they currently get all the nourishment they need from the placenta directly into their bloodstream, they will need to be able to swallow and digest from the moment they're born. For this reason, they start to open their mouths and drink in some of the amniotic fluid that surrounds them. You can see their early efforts clearly in this 4D scan. Some of the flavour from the food the mother eats is transferred through the placenta into the fetus's bloodstream and then out into the amniotic fluid. The fetuses sample it as their taste buds develop. With their senses developing apace, our fetuses are about to begin using them. Twins and other multiples are known for a particular characteristic in utero. Scientists have even witnessed them playing games together. We're 20 weeks into gestation. The fetuses are about 140 millimeters, small enough to cradle in the palm of their mother's hand. They cannot open their eyes yet, but the main structure of the eyeball is complete. The iris, which controls the amount of light that enters the eye, is forming, but the pupil does not appear until closer to birth. The 5th month is an important time for the nervous system. The number of nerve cells increase rapidly, 2.5 million neurons per minute. 100 billion by birth. Their biggest task now is to grow. Yet this is also about to become their biggest problem. A woman's womb can contain a fetus of up to approximately 5.5 kilos. Usually single babies are born at anywhere between 2.5 and 5.5 kilos. Twins between 2 and nearly 3 kilos, and triplets at between 1.5 and 2.25 kilos. Quads and higher multiples are sometimes born at just 1 kilo each and need weeks of intensive care. The taller a woman, the longer her abdomen and the greater weight she can carry. We're 24 weeks into development. The lungs will start to form surfactant, which helps babies breathe after they're born. It's a greasy substance that allows the lungs to separate while a breath is being drawn. Because higher multiples are almost always born prematurely, doctors give the mother a steroid to help surfactant form. Our babies are now too large to be captured collectively in the field of a 4D scan. But for the first time, their mothers will see them interacting. As each baby appears individually, it's often possible to see the limb of one of the others. These 4D scans show one twin pushing against the other. Even those fraternal twins, in their own chorions, feel their neighbour impinging on their space. Though space is becoming cramped, our twins and other multiples are about to start engaging in one of the most fascinating of all prenatal developmental activities, game playing. What's more, some of these apparent games seem to persist even when the twins are outside the womb. In one case, a pair of fraternal twins were regularly seen in scans, cheek to cheek, either side of the dividing chorions. At about 1 year of age, these twins' favourite game was to stand on either side of a curtain and begin to laugh as they touched each other through the fabric. Scientists think their prenatal behaviour simply carried over into early childhood. It's 26 weeks into gestation. Suddenly, the eyes open as the eyelids separate for the first time. And some scientists believe the babies can now see. In the darkness, the fetuses might just be able to make out the shapes of their siblings. For singletons, the view is limited. For twins, there's much more to take in when light occasionally penetrates the womb. The inner and middle ear, which have been growing since week 4, are now fully formed and functional. The fetuses can hear the mother's heartbeat and the rushing sounds of the amniotic fluid. They can also hear muffled sounds from the outside world, including music and voices. We're They're now 28 weeks into development. One of the things the doctor pays particular attention to is the umbilical cord. This masterpiece of natural design is thick and resilient. It contains two arteries and a vein that coil around each other in such a way that they don't get knotted or kinked. Even if the umbilical cord wraps around the baby's neck, it can still deliver the vital nutrients. But for twins sharing an amniotic sac, this life-giving supply line also presents a unique danger. Identicals can get entangled in each other's cords, cutting off the flow of food and oxygen either to themselves or their co-twin. This 4D scan shows just such a situation, with heavily entangled cords. The main reason that identicals who share a single amniotic sac are often delivered by caesarean is to reduce the risk of entanglement at the most critical moment, when the babies are born. In the last weeks before birth, the babies are putting on as much weight as they can. The larger and stronger they are, the better. While doctors monitor the ongoing health of the fetuses from the outside, the fetuses' bodies can also regulate and control their development, at least to some degree. If one twin is not receiving enough blood in the womb, his body will take steps to preserve the all-important brain. He is actually able to regulate the volume that different parts of his body receives. In this case, pumping only a limited amount to his extremities, which need it less, and redirecting more blood to his brain, to prevent it being starved and therefore possibly damaged. It's 30 weeks. Now the fetuses have everything in place. Intricate details like their eyelashes have formed. For single babies, this final 10-week period is about one thing: growing. But for multiples, it's not so easy. There's no space left in the womb. The babies are doing a lot of pushing and shoving as they compete for room. The eyeballs can move in their sockets and react to the light. It's been observed that if a strong light is shone on the abdomen, the baby will react to it. "32 weeks. Single babies would still be about 8 weeks from birth, but for our triplets, the big moment is much closer. All multiples present a medical challenge. A delicate balance between leaving them inside long enough to be sufficiently large at birth, but not so long that they endanger the mother or themselves. Critically, their lungs must mature fully enough for them to breathe on their own. 34 weeks in the womb is ideal for triplets. Because of the dangers of natural labour, the doctors will recommend a caesarean. In Jennifer's case, the doctors decide not to wait until 34 weeks. Instead, they settle on 32. Jennifer has chosen to have a local anaesthetic. With no pain in her abdomen, She will be conscious the whole time. The surgeon prepares to make the first incision. Inside, the babies are unaware of what's coming. Caesareans are always performed quickly to reduce the risks of complications. A surgeon cuts the membrane. The first baby is out. It's one of the identicals, a boy. The baby takes his first breath and emits a healthy scream. The cord to the placenta, which has been his lifeline for 8 months, is finally cut. Working briskly, the surgeon looks for his identical brother, who is in the same chorionic sac. He's out quickly. But there is a delay to find the final fraternal brother. He's in his own chorionic sac. Finally, he too emerges, feet first. The 3 babies are fit and healthy, despite the cramped conditions of the final few months. They weigh the triplets. They're just over 2 kilos each. But they're 8 weeks premature. High-tech incubators that imitate the cozy world of the womb will help them to put on weight and bring their lungs to maturity. In undeveloped countries, multiples are placed together for warmth and comfort. Rachel's twins are about to be born. They spent the past 38 weeks in the womb. The baby's lungs are robust and their bodies are ready. At birth, twins normally weigh just over 2 kilos. Their smaller bodies make them good candidates for a natural birth. This is what Rachel wants. She had 2 children like this before and feels confident and capable of a natural birth. A hormone triggers labor. The baby normally turns head down as the pregnancy comes to term. With 2 in the womb, this is more difficult. The baby positioned nearest to the head of the birth canal will be first. The amniotic waters are broken. The baby's head pushes through the remnants of the sac that protected it for 9 months. With the cervix fully dilated, the muscles of the uterus continue to push the baby towards the outside world. Rachel has been pushing for 3 hours. The first baby begins to engage its head, and Rachel gradually pushes the baby out. It's a boy, weighing in at just over 3 kilos, a healthy weight for a twin. For the first time in 9 months, this baby has a womb all to itself. 10 minutes after the first birth, the head quickly appears, and the second baby follows her brother out into the outside world. This time it's a girl, at a lighter 2.7 kilos. After being separated for a few minutes, the fraternal twins are reunited. The quads have reached 29 weeks and 3 days. The doctors decide that it's time to operate before the risks get too great. With a large number of medical staff present, all focus is on the mother and the impending birth. The surgeon cuts through the abdomen and tries to locate the first baby. Each has its own inner amniotic sac. Cutting through the first amnion, the baby is out quickly. It's a girl, just under a kilo in weight.
Happy Mother's Day, Jennifer.
There she is.
She is followed by the second baby, another girl, who is equally small. The team takes each baby to check their vital signs. The biggest concern is whether the babies can breathe unassisted. These babies are being born almost 11 weeks earlier than singletons. The doctor grabs the third, smaller baby. He removes it from the uterus, and it is taken for examination by the midwife. With only one baby left, this extraordinary quadruplet pregnancy is nearly over. The final and fourth baby is eventually delivered. All four are girls. Incredibly, they all weigh about 1 kilo, 1/4 of the weight of an average singleton. They too will have to spend several weeks in incubators to mature to a level where they can go home. Rachel's twins are 8 weeks old, but have been growing together for almost a year. Each is beginning to acquire their own personality. And though they are fraternal rather than identical, they are pretty similar, influenced to some extent by their genes, and to some by their shared time in the womb. Although identicals will be much more similar, a product of their close genetics, their upbringing will also play a part. Jennifer's triplets are home from hospital. They can now breathe on their own. At this young age, all three seem very similar. But as they grow up, the fraternal twin is likely to diverge more than the two identicals. Julie's quads are now 3 months old and putting on weight fast, despite being born at around 1 kilo each. Julie and Jose feed them special formula milk with extra calories to accelerate their growth. It's taken this long for the four to reach the average birth weight of just over 3 kilos. Even today, with modern medical advances, multiple births remain reproductive miracles. Although they are only a small percentage of human births, they hold a fascination for us all. For science, they are not only a challenge, but also a window on reproduction, giving greater insights into the remarkable world within the womb. And for our twins, triplets and quads, those early interactions with their brothers and sisters in the womb will connect and define them as they grow up, and provide a source of comfort and inspiration throughout their lives.